This is another one of my summer projects. It's inspired by a 3 blue, 1 brown video where he animated an image drawn as a sum of rotating arrows. In this case, I took it into 3 dimensions. And you can see a circle here, a purple circle, that's sort of like the base of everything. And then from that, you can draw some green lines here. And we add them all together. They trace out this yellow path here, like the very last arrow will trace out that yellow path. And the way I've set this up is that they're all going to be in the same plane at any given moment, all the green lines. And the first one that's connected to the purple circle is constant. It doesn't really rotate at all. And as you go further and further away, they start to rotate faster. And so the math that this uses is the fast Fourier transform, which lets you represent a signal as a sum of rotating vectors, or complex sinusoids, if that's another way of calling it. So the only thing that really matters is their starting position and starting angle. And once you have that, you'll see later you can trace out any signal, pretty much any signal that you want. And also, I'll show this later, but you don't even have to start from a circle. You can start from any purple loop, so long as it intersects, like the plane that's perpendicular intersects the target yellow line at every single point. And yeah, so here I've got some of the methods I added, or I created here, some fast Fourier transform methods. This case only used the one-dimensional FFT and the inverse FFT because it's technically like a two-dimensional signal, but the second dimension is the imaginary component, so you can pretty much do it with just the one-dimensional FFT. And then the overall system here was in a tutorial that I watched for game development that let me set up the 3D environment and have a movable camera and render entities. And I really had to do this if I wanted to render more than a certain number of hundreds of triangles on screen at a certain time. And so this was good for that. And pretty soon I'll show the case where it's the same yellow line but with a different starting purple loop. Yep, that'll be it for this first part. So now running this program with a different starting purple loop instead of a perfect circle. This time it's completely different. It's a different loop in 3D space. The yellow line in this case is exactly the same. And what the program has done is it's changed the initial sizes of the green line segments and also the initial angles. And from that, that's all the information that it needs to trace out this entire yellow loop is just that initial position and initial angles. And that already stores all the information. And there's some effects based on the way that this, these green lines being in the same plane. Sometimes it'll trace back on a path that's already done. And that's just because of where the plane sort of intersects the yellow line. Sometimes it just happens to go back where it's already been. And then another thing is that once it completes a full revolution around this purple base, it'll do a little bit of a jump just to get back to its initial positions. If I wanted to remove that, I'd have to manually set up some of the way the program is generating the plane and the basis vectors for that plane. But for this demonstration, there's just a little bit of a jump. And that's about it, I think, for this little demo here.